In today's video we will talk about overclocking the Intel 9th gen, so 9900K, 9700K, 9600K, doesn't matter which CPU you use because all of them behave exactly the same overclocking wise, and we will use them on ASUS motherboards today, so C390, doesn't matter if it's a Strix or a Maximus. Personally, I'm using the Maximus XI Extreme. Extreme nowadays is a board that's meant not for extreme overclocking, but for especially water cooling enthusiasts. We have some additional features on there, such as water cooling headers, like a flow sensor, temperature sensors. So if you're going, for example, for a hard tubing build, this could be your choice. For extreme overclocking, like real extreme overclocking, dry ice or liquid nitrogen, we still recommend using the Gene, because the Gene is using only 2 DIMM slots and therefore we can achieve higher memory clocks on the Gene. Before we get to today's overclocking guide, we will take a look quickly at STDKey, which is the sponsor of this video. It's an online store where you can get keys for games and software. For example, you can find the recent Call of Duty Black Ops 4. You can also find, for example, Red Dead Redemption 2. Those are 2 of the very popular games on this website, and apart from that you can also find Windows software such as Windows 10. Find out more in the description below, where you can also find a code for 10% discount. Okay, so let's start. And the setup today, as I said, is based on the Maximus XI Extreme. I'm using it in combination with a pretested 9900K from Caseking. So if you're getting one of those Bauer pretested CPUs, you will find the clock and the voltage written on the CPU package, and that's what we can use later and dial it into the BIOS. I will show you at which points. I'm also using a Noctua NH-D15 air cooler, which is a very solid air cooler, and it's absolutely recommended and necessary for a 9900K. It's pretty much what I would recommend you to use if you want to go for an air cooler. If you want to go for an AIO, you should really use at least a 240 or better a 280 AIO. If you can, use a 360 AIO, because the CPUs can run extremely hot, especially if we go above 1.25 volt or above 5 gigahertz. We need very solid cooling solutions. Then I also have the ASUS Thor PSU, which is manufactured by Seasonic, so very high quality, and personally, you've probably seen it in one of my previous videos, that you have this feature where you can see the power consumption on a small OLED directly on the PSU. I'm a big fan of this feature because, yeah, I'm just sitting here and I can directly see the power consumption on the PSU instead of looking underneath the table where I'm looking at one of those smaller devices. So it's very convenient to use the Thor PSU. I'm also using an RTX 2080 Ti Strix, which is not really necessary in this video because we will just do CPU OC, so we will not talk about the graphics card. I'm also using G.Skill memory kit 3600 C16. Nothing really special. I would personally recommend that you go for memory speeds between 3600 and 4000. Personally, really above, it's not worth it. Like, so I see so many people buying memory kits with 4800. Personally, I really think it's kind of a waste of money because, yeah, you should rather invest the additional money for, I don't know, better GPU or better CPU. Anyway, I'm also using DIMM.2. I'm really big fan of the DIMM.2 modules, especially that nowadays a lot of mainboards, I'm not a fan of that. On some mainboards you have to remove the PCH heatsink, and then you have the M.2 heatsink or the M.2 slot underneath the PCH cooler. So it's extremely inconvenient if you have the mainboard set up inside the system already and you want to change, for example, the M.2 drive. I have to remove the GPU, especially if it's a hard tubing system, and then I have to take out the mainboard to access the screws from the backside of the PCH cooler, remove it. So yeah, not a fan of that. That's why I really love the DIMM.2 module, because you can simply take it out like a DIMM slot, like a DIMM module. So yeah, DIMM.2 is the way to go. Before we start talking about the manual overclocking, we will quickly talk about AI overclocking. And previously, I've never been a fan of like automated overclocking, no matter which mainboard manufacturer. Typically, it never really worked nicely. It always applied too much voltage, or it didn't really work. Yeah, I've never been a fan of automated overclocking, but AI overclocking, it really surprised me. I'm not kidding here. So if you go to the BIOS and if you press F11, you go to the AI overclocking guide. There's a lot of information there. I would recommend to you that you just read through it. To just sum it up, AI overclocking is really AI overclocking. So the CPU or the mainboard is learning from what you're doing. If you just set up your system, the first steps you should take is you leave everything on auto. You maybe enable XMP, you go to Windows, and then you run some basic load. So maybe perform 5 Cinebench runs, and then you go back to the BIOS. So if you go back to the BIOS, on the bottom right side, you can see the prediction values. And here you can see the silicon quality and the cooler points. Don't be confused, silicon quality values are only available on the very early BIOS versions. Not sure why it's removed on the newer ones, but on the newer ones it's not visible anymore. The value is not really important anyway. Basically, the silicon quality is nothing else than the CPU VID. The silicon quality is nothing that exists on the CPU. I really want to point that out because I read on some forums already online that somehow ASUS found a way to read out the silicon quality. That's not true. There is nothing like that. There is nothing stored in the CPU that's called silicon quality. It's just a value that ASUS created for you to make it easier to judge how good the CPU should be. Also, because the silicon quality is just based on VID, it will just give you an early prediction. It will not really tell you how good the CPU is. You have to test it manually to see how good the CPU really is. And then you have the cooler points, and the cooler points are really, really interesting. So while you have been testing your CPU on the first run, so you ran some Cinebench load maybe 5 times, the mainboard has been recording the CPU power consumption and compared it with the CPU temperature. In this way, the mainboard can predict how good your cooler is, and that's where it gets really interesting. So you have those values on the bottom right where the mainboard is predicting how good the CPU should run. So we see if we clock the CPU to 5 GHz, it would tell you that you need a voltage of 1.2 volt. Now we have something that's CPU core ratio, we go to AI optimized. If you do that, the system will automatically overclock your CPU based on those values, and it will also learn over time, which is absolutely impressive. I've never seen something like this before that is learning this well. So as I told you before, you have the cooler point, which in my case is 168 points, which is quite solid, very similar to an 240 to 80 AIO. And for example, you keep running your system, I don't know, like 3 or 4 years, and you don't clean it. So your radiator or your air cooler will collect some dust, the cooler performance will suffer. The cooler points will decrease, and therefore the estimated overclocking will also decrease, and the system will do that automatically for you and will make sure that the overclock is staying stable. So if you want to use that, it's a very interesting feature. You can play around with it. I also recommend that you take a look inside the AI features here. There's a lot where you can play around with. You can, for example, change the optimism scale. You can also do this to recalibrate the cooler. So if you enter this, the cooler score will be recalculated again. So you can see it dropped now to 144 points, and then you can perform the testing again. I don't know, if you changed something on your water cooling loop, for example, then you go to recalibrate cooler. Really, there's a lot you can do with that. I recommend that you invest some time and play around with the AI overclocking features here. If you use the feature and you found your stable values, you can also decide that you want the system to stop training. So if you want to do that, go to cooler efficiency and you can do stop training. In this case, your system will ignore if the cooler score changes over time. You can also simulate a different cooler score if you want to. So for example, if you use a very weak cooling solution like a 120 AIO and you want to simulate what a 360 AIO is capable of. So you can change this to 180 and then simulate whatever AI overclock the system would give you if you would upgrade your cooling solution. So there's a lot you can play around with. It's very interesting, I can tell you that, and it works really nicely. So if you want to use that, it's a cool feature to play around with, but we will today do the manual overclocking. So let's start with that. So first step obviously is adjusting your memory to XMP. Even if you plan not to overclock your system, some people buy a system and then they say, okay, I might not overclock it now, but maybe in 2 years if I need the performance. You can do that obviously, but don't forget to set an XMP because you paid for the high memory speed, and if you're not using it, you wasted your money. So adjust XMP. Click no here because this is the multi-core enhancement. It will allow your CPU to draw higher power. I do not recommend to use this feature because we will do manual overclocking anyway. If you don't do manual overclocking, if you just want to set your XMP, you can set it to yes if you want to. AVX instruction core ratio negative offset will basically lower your CPU core speed if your CPU is encountering AVX loads. And AVX is an instruction that will use or utilize your CPU much heavier, so power consumption is a lot higher. That's why this should be set to 4 from our experience. You can also adjust it to 3 if you want to, but I experienced some cases where the AVX load was so high that it would crash, so I would recommend to use AVX ratio offset of 4 just to be safe. CPU core ratio we set to single cores, then we set it to 50, which will basically overclock the CPU to 5 GHz across all cores. What I really like about the Maximus 11 series is that you can see what kind of CPU load line calibration is set by default. In this case it's level 2, and level 2 is actually quite low. I would recommend that you go for level 6 or level 7, it depends how much voltage drop you want to encounter in Windows or in load. I would say that you start with level 6 first, and then we would check in Windows how much the voltage drop looks like, and then we can maybe increase it later to level 7. Also set the CPU current capability to 200% to basically disable OCP of the mainboard. Then we go to internal CPU power management, and we set all the power limits to the maximum. Mostly this is not necessary that you have to do this, but it depends on the exact mainboard model and also the exact BIOS version, what settings are set by ASUS in the background by default. That's why I recommend to just unlock everything, and then you will be sure that the CPU will not be held back, that there will not be any power limits running in the background. Same goes for the CPU core cache current limit max. Just set it to the maximum, and then your CPU will not throttle in any condition. CPU cache ratio, set it to 43, which is basically stock. You can always go back once everything is running fine, once memory is tested, once the CPU is tested, you can always increase this. Most CPUs can run 46 or 47. You can get like 1 or 2% extra performance if you increase those afterwards, but just make sure that the CPU core is running stable first. Manual mode, and on the CPU we have here on the box was written 1.29 volts, so the CPU was pre-tested from Caseking 5G 1.29, and that's the value you have to enter here. CPU, VCCIO and system agent voltages. Those voltages are mainly needed for very high memory frequency. So if you apply this now and if you would go back to the BIOS, you would see values here typically around 1.2, 1.3 volt, obviously also depending on your memory speed. You can later try to adjust those manually. VCCIO maybe 1.15 and CPU system agent maybe only 1.1. From my experience, you can always lower them from auto and therefore also lower your system power consumption a little bit and also decrease the temperature afterwards. So that's something you can play around with. So once we have set up all of this, we just go to the ASUS profile, give it a name, save it, and with F10 we apply the settings and go to BIOS. Go to Windows. Alright, so we entered Windows, we opened all the necessary tools, so CPU-Z, Cinebench and Hardware Info are the tools that I would recommend you use for the basic stability testing. So in CPU-Z, if we just right click, we can see CPU is running at 5G across all cores. We can see the core voltage is currently at 1.288 volt, which is what we need for the CPU to be stable. So 1.29 volt is what is written on the CPU package from our pre-testing at Caseking. So what will be interesting is if we will now run Cinebench R15 multi-threading to see how much the CPU voltage drops under load. It might be that it's necessary to readjust the load line calibration afterwards, maybe increase it by one level. If we go to memory, we can see that the cache clock, which is the one on the top right, don't be confused by the North Bridge frequency thing here. That's not correct. It should be called cache frequency. So it's 4.3 gigahertz. We can see the memory is clocked perfectly at 3600 megahertz. It's only reading out half here, so don't be confused by that. So everything is correct, all the settings. We will quickly do a Cinebench run just to see if we have the basic performance and what the performance looks like. Also check if the cores are stable all the time, and we expect typically a score of 2100 to 2150 points in Cinebench R15 using a 9900K at 5G. We can see with 2145 points, we're perfectly in line. If the CPU would throttle, if there would be any kind of power throttling, or if it would hit a temperature target, you would immediately see it in the benchmark score. So 2145 points is perfectly fine. Sometimes it will fluctuate by 50 points or even 100 points depending on which Cinebench version you're using, because there are two different Cinebench versions of the Cinebench R15 out there. If you're using the older one, you will have a little bit less points, so make sure that you have the latest Cinebench R15 version, and also make sure that nothing else is running in the background, because sometimes I'm getting messages and comments that, hey, my score is 100 points lower than yours, is my CPU damaged? Of course it's not damaged. If your CPU can pass Cinebench, it's not damaged. You might have a lower score if something is running in the background, so make sure, open Task Manager, double check that nothing else is running in the background, and then you should be fine. So if we run the Cinebench R15 again, we can see that the CPU voltage drops to 1.243 volt under load, which is fine, which is healthy for the CPU, that the load line calibration works like this, that you will have a lower CPU core voltage in load. But the CPU is tested at 1.29 volt in load. That's what we write on the box at the Caseking pretested CPU. So you would actually have to increase the CPU voltage in the BIOS or increase the CPU load line calibration at this point. We used the level 6 before for this basic setting, and I would probably go back to BIOS now and increase it to level 7, double check afterwards what the CPU core voltage looks like, but it seems to be fairly stable at this point, so we will just leave it like this for now. We can also check hardware info for the CPU temperature. For example, we can see that the CPU hits up to 80 degrees Celsius using a Noctua NH-D15, which is a very solid air cooler. So yeah, 9900K, as you have seen in the previous video, is running fairly hot, especially if we increase the voltage to something like 1.3 or even above 1.3 volt. We can do that afterwards once we've done the basic testing and see what the power consumption and temperature looks like. If we scroll down further, we can see the power consumption details. So CPU package power in this case, if we run Cinebench R15, we have roughly 180 watt power consumption, which is fairly a lot. And if we run Prime 95, especially at the small FFTs, we will see even higher power consumption. So make sure that you have a suitable CPU cooler. You can see the CPU package temperature went up to 84 degrees Celsius, which is still fine. No worries about that. If we scroll down even further, we have the ASUS EC and we have the ASUS VRM temperature. As you can see, the VRM temperature in this case so far is 45 degrees Celsius max if we just run a few Cinebench runs. Of course, if we keep running Prime 95, especially if there is no airflow around the CPU, the VRM temperature will increase. Everything below 100 degrees Celsius VRM temperature will not be an issue, and I don't even think on this board that you will hit the 100 degree mark if you use a setting like this, like 1.25 to 1.3 volt at 5G. You should not have problems with the VRM temperature across the whole Maximus series. From what I've seen, you should be fine. So to do the stability testing, we will use Prime 95 in the version 26.6, which is a version that's not using AVX. You can also use the newer Prime 95 versions and disable the AVX manually, but it might be easier to just download 26.6. Use custom, and I would recommend that you use a minimum and maximum FFT size of 12. 12 is really intense. It's causing the CPU to consume a lot of power, so this is really simulating the worst case, and if this passes for 1 hour, you can be sure that it will also pass the gaming performance. If we fire this up now, you can see that the CPU immediately hits a temperature of something like 90 degrees Celsius under load. So it's really running hot, especially if you keep it running during the summer or keep it running for 1 hour. You will see even higher temperatures, but don't be afraid. Even if you see 95 degrees Celsius for a short time period, it's really not a problem for your CPU. Don't be worried. And if we scroll down, CPU package power in this case already 195 watt. So yeah. A strong cooler is absolutely recommended for the 9th gen of Intel. You can see the VRM temperature is slowly increasing now, 46 degrees Celsius now. It's still really cold. From my testing on this CPU with the air cooler, because the Noctua NH-D15 will blow some air over the VRM cooler, it will not hit anything above 70 degrees Celsius, so you should be really safe with this board if you're using an air cooler. If you're using an AIO or custom water cooling, just make sure that you have some case fans somewhere in your system that are providing some fresh air over the VRM, and then you should be perfectly fine. What we can do now quickly is that we just clock the CPU a little bit higher, also increase the core voltage. I just want to see that the CPU can take much more than what you probably think, and it's also protecting itself, so we will just simply push it to 5.1 gigahertz now at 1.42 volt idle, so load is probably 1.36. We will just take a look at the power consumption quickly, because actually those voltages would be required to clock the CPU to something like 5.1 or 5.2. And if we rerun this, you can see the power consumption is now like 220 watt. And you can see it's too much for the cooler to handle. You can see it's immediately 99 degrees Celsius and the CPU starts clocking down. So the CPUs are capable of very high clocks. So 5.1, 5.2 would be doable with most CPUs if we would be able to cool them down. So if you have a very strong custom water cooling loop, there are plenty of CPUs that can do 5.1 or even 5.2. Also the pre-tested CPUs from Caseking, like this one, is set to 5G 1.29 volt. The CPU can easily do 5.1 if you have a custom water cooling loop, but obviously we cannot ask every customer to have a custom water cooling loop, so that's why we assume that you're using something like a 240 or 280 AIO and some decent ventilation in the case, and then this can easily do 5G. So that's it for now. I hope you enjoyed this. I hope you got some good information out of this tutorial. If you have any kind of questions about overclocking in the 9th gen, feel free to put it down in the comments below. See you soon.